All right, thank you so much. So yeah, I guess Max and Ananya have seen this, so you can answer emails. But then I'll also spend some time talking about a different project from the same data. So in this paper, I'm motivated by this discourse in popular media that social media is largely bad for the world. And in particular, the concerns that I'm most interested in are those of offline violence driven by online content. So in the case of Myanmar, in the case of the Capitol Hill riots, and closer home in the case of India, where there's a large digital ecosystem that operates and has been linked to sort of offline violence against India's Muslim minority community. So sure, we all agree that the platform's algorithms have been blamed to drive people into these echo chambers, and it is hard to regulate these platforms because the trade-off that these platforms face is engagement maximization versus safety. And engagement maximization would mean that we are sort of driving people into these harmful echo chambers. So empirically, the problem is that we want to measure the effect of personalized feeds on harmful engagement, but this is inherently difficult because of the role of preferences that drive both personalized feeds and harmful engagement. So in this experiment, I break this correlation between preferences and personalized feeds by basically running an experiment where I turn off the algorithm for about 2 million users on this platform that is a TikTok replacement in India. And when I say I turn off the algorithm, I mean that the algorithm is replaced by a random draw of content. And the control group, which is about 6 million users, is business as usual, where users are being recommended content based on their previous engagement with content on the platform. So this leads me to 3 research questions. The first one being, does turning off the algorithm in this way weaken echo chambers, where echo chambers are measured as concentration of what users are consuming in different topics. So the HHI with respect to topics. And then I measure offline outcomes like political attitudes and mental health. The second research question is, does it reduce engagement with toxicity, where toxicity is measured as something that is rude, insulting, or attacks someone's personal identity, and engagement is measured as the number of shares of the platform into WhatsApp. And finally, thinking about the trade-off that I motivated this talk with in the previous slide, thinking about what is the cost of the intervention for these platforms, where costs are measured as overall platform usage. And then that helps us quantify these trade-offs between profits and safety, and also think about what would happen under different counterfactual policies. So when the algorithm is turned off and replaced with a random draw, the treatment essentially converges to the average feed on the platform. So this means that content exposure to different topics now changes. So whether it's religious content, good morning posts, or also news and political posts over here. So mechanically, the treatment is going to increase exposure to a diversity of different types of content. And so, however, I find even though there is a mechanical increase in exposure to different topics, echo chambers still seem to persist because concentration of topics in the shares actually increases in this experiment. So this leads me to conclude that users seek out preferred content, as I also find that there's an increase in the number of searches as in Homa's work, and also users report spending more time on other platforms. There are no offline effects in survey outcomes measured at the end of the 11-month experiment, and I measure mental health as well as political attitudes.
You switched off the algorithm for 11 months.
Yeah, but these results are, the survey is at the end of the 11 months, but the results from the admin data are for the first month.
The no effects is treatment versus control.
Yeah.
So there's no illicit prior.
No, they didn't have IRB.
Yeah.
Target the users. So the users were, so the randomization was at the individual level. So just 1% random sample out of the entire 200 million user platform.
So that if only you look at one behavior, which is toxicity, you can actually use this data for others.
Yes, that's it. Yeah. And so for example, like here, I will focus on toxicity, but you're right that there are some types of users, for example, type D users who are used to seeing more toxic content at baseline. So mechanically, these guys will see less toxic content, but type M users who don't see a lot of toxic content at baseline, they're now going to end up seeing more toxic content. And so I use this to sort of think about how we can, I use this in a model and then think about counterfactual policies, like, for example, targeting feeds, but that is a policy that cannot be implemented in the real world. For example, the platform wouldn't want to censor posts that I think are toxic, because that is a very subjective call. This is a classification that is done sort of ex post. Yeah.
When you say that routine persist, that means that treatment versus control is the same, or
There's actually an increase in topic concentration in shares, a decrease in topic concentration in views.
Okay.
But and that's mechanical, the first
Yeah,
part,
makes sense.
but an increase in the shares. So
That's kind of weird.
yeah, so I will show you some, so I did decomposition, and it's mostly driven by the fact that people are sharing a lot less. So the denominator is changed.
So it could be that they're also being targeted with less like non-toxic content that's personalized and therefore they show less stats.
Yeah, but I think there's also, so in the echo chamber measure, I'm including different topics, not just toxic content. And so it could also be that they're not getting their diet of good morning posts.
So that's like the absolute number of toxic shares
That is falling,
that is falling.
yeah.
So which is kind of inviting for it.
I think so, yeah, overall, but again, this is in partial equilibrium, in the sense that.
Yeah.
I suppose, like, if you were to treat everyone with a random, or like with this kind of random algorithm, then producer incentives. Yeah.
The T and N are distinguished by the ex ante fraction of toxic content. So like, is there one interpretation of this graph is like the N weren't seeing the toxic content. So of course, there's nothing for them to change. The T are now seeing 27% less toxic content. And we're previously sharing 100% of all toxic content they saw. And that's why it was down by 27%. Is that kind of
But the ends see more toxic content.
Yeah. So this
right?
is,
But they were sharing 0% of it to begin with. So it sort of doesn't change.
so they were, before they weren't seeing anything, and so not sharing anything. Now they're seeing more. Yeah, and for the type D users, so they were seeing a lot. Now they're seeing less, but then they're also sharing less. So before, I will show you that, say they were sharing some X% of toxic posts that they saw. After being treated, they share Y%, where Y is less than.
Yeah, okay, that's like
Yeah. And so I will decompose this main outcome, which is the total number of toxic posts that are shared, into its constituent parts. The first one being just the mechanical effect of the intervention, which is the total number of toxic posts viewed. And here I find that there is a mechanical reduction. And the second component is the overall change in engagement with the platform, which is measured by the number of posts shared. And finally, what I'm thinking of as the behavioral component of this decomposition, which is interpreted as the probability of sharing something toxic conditional on viewing it. And here we find that for the average user, the treatment effect is positive, 19%, which means that even though the average user is seeing less toxic content, when they see it, they're more likely to share it. And the treatment effect for type T users on this conditional probability is actually larger, much larger than the average user.
So the story would be that the T types really want to share some toxic content that was to see one.
Right. Yeah, because they're on average, they're seeing a lot less than before. In terms of the literature, I'm placing this paper in the literature on persuasion effects of biased media. And also a big strand of this literature focuses on demand factors directly. I'm most closely related to these papers that were studied. The algorithm was studied in collaboration with Meta around the 2020 elections, where they switched from the usual recommendation algorithm to a reverse chronological algorithm. I'm able to differentiate this paper from those papers primarily because on a platform like TikTok, there are no social networks, which would mean that the treatment is actually more extreme than a reverse chronological feed, which would still depend on people's social networks. And in my case, the ITT is completely orthogonal to preferences because the platform users and the random algorithm does not depend on any social networks at all. So for the rest of the talk, I'll guide you through the background, the experimental design. I'll establish the main treatment effects and also think about heterogeneous responses, which are very important in this setting. So in India, 83% of the people have access to some form of internet, and 68% of these users are on social media. Making this the second largest market for social media platforms with about 600 million users. And most of these users are using mobile broadband, which will become important for the next paper that I will present today. So the platform is a TikTok substitute. TikTok is banned in India, giving these guys a majority of the market share. And I'm not naming the platform, so I'm going to use the pseudonym TikTok for these guys. As I said before, and this is a very important distinction, there are no networks on this platform between users. And so you can, in principle, follow users, but nobody really does that. And the algorithm also does not optimize on increasing followers or followers. Users can view, like, or share posts to WhatsApp, and posting to WhatsApp is also sort of one of the big features why this platform is very popular in India, because most of the social media users are WhatsApp users. There's 15% video content in my sample, and 85% are images with texts like "Good morning," which Ananya sort of talked about a little bit. Apparently, it's not just an Indian grandma thing; it's a developing world grandma thing. So I hear these are very popular in North Africa as well. And just to give you some more illustrations, there's a lot of religious content of both Hindu and Muslim genres. There's cricket, cooking, and cats and dogs dancing Bollywood. There's political content, but that is by far sort of the least popular kind of content on the platform. Only 1% of users are engaging with political content. So the data is at the user post level. So I know views, I know who is sharing what.
Do you think toxic is a subset of political, or just two separate?
So I'm labeling everything, but I'm also looking at the intersection of political and toxic content, which is what is mostly anti-Muslim.
Aarushi, and feel free to defer it toward the end, but like, would love to get your thoughts on the broader conversation about like how much of a problem these algorithms and platforms are if such a small percent of all like consumption is like political consumption, then on top of that you're looking at the intersection of toxicity and political content.
Right.
I mean, feel free to defer it, but I would just love to get your thoughts.
Yeah. Yeah, I think like I still think it's a problem, even though it's 1%, because some of these posts tend to be very extreme and can cause damage. There's also a temporal element to this. For example, platforms like this one were used around, say, the riots of 2020 in Delhi, where a lot of content was actually TikTok was not banned in India, so the primary channel for rioters was TikTok. And again, it's a very small fraction of Indian TikTok was political. They were able to coordinate such they were able to out locations of people who were then attacked on social media
In
platforms.
some sense, that's surprising given that there's no social network on these platforms.
Right. So I think the TikTok algorithm did use location. So you could say that I am in West Delhi, and this is where these guys are hiding. So there was a lot of that kind of content and like showing someone's climbing on top of a temple and getting the flag down as a way to monger fear. Yeah. Okay. So here, what is also important is that I also know the ranking of posts in users' feeds on each day during the intervention period. At the post level, I mainly use text data in this paper, although I have some work with Lorenz where we're trying to use the images and videos themselves to see if there's more information that we can extract from beyond just the text on these images. And then at the end of the survey period, I conducted a telephonic survey where I asked them questions about political attitudes, mental health, but also very importantly, time spent on other platforms, which is something I cannot get from admin data. And user level data is used to characterize heterogeneous treatment effects. And here we don't have a very good measurement on gender and age, but time of account creation is again obtained from the admin data. So the first outcome is measuring echo chambers with topic-based HHI. So the first step here is to extract embeddings of about 20 million posts. Again, this is embeddings of the text of these posts. And then cluster these embeddings using a k-means clustering algorithm. And those clusters characterize topics. And then I characterize each of these topics using LLMs. So I basically ask in parallel to the embeddings, I also prompt an LLM with each post where I ask it questions about how toxic a post is, how anti-Muslim, whether it's political or whether it's religious, it's Hindu religious, Muslim religious. But I also ask it how likely is it to cause social outrage. So here, for example, cluster number 50, which happens to be the news cluster, has 22.5% of this content is anti-Muslim, and also about 35% of this content is likely to generate outrage. And then once I have these topics and I have the ranks of these posts, I can then construct a rank-weighted HHIs for each user.
So logically, why is it necessary to first cluster?
How would you do it otherwise?
I'm just wondering, maybe you clearly lose information, right, by putting these things in like a low number of discrete categories.
Right. But then I wanted to make it track.
That's what you really care about, some kind of dispersion in like embedding space.
I see.
Right?
Yeah,
Right.
yeah,
Of course, again, the question
Yeah.
arises how to measure dispersion.
right. Yeah, I see. So then one measure of like echo chambers could be just looking at, I guess, very sort of the
Yeah,
posting.
whatever the right measure of dispersion there is.
Right. Yeah, I mean, one thing could be, I guess, like cosine distance from the average embedding or something like that.
Like you clearly, you're within cluster variation, right? You're only capturing the cross cluster variation.
Yeah. Okay. And the second outcome here is toxicity, where right now I'm measuring this using an algorithm developed by engineers at Google called Perspective, which classifies a post as being toxic if it's rude, disrespectful, or so unreasonable that it is likely to make someone leave a discussion. And here is just the distribution of the continuous toxicity scores. I then discretize this continuous toxicity scores just to make the analysis more tractable. And I end up at a threshold of 0.3, above which I classify a post as being toxic, and below which a post is classified as being non-toxic. And I validated this measure and find that 0.3 seems to be doing well and is also the threshold that I pre-registered. For the design, the algorithm is basically generates a ranking of posts in each user I's feed by taking the cross product of user embeddings, psi I and phi j, which represent the post embeddings. So the treatment essentially replaces these user embeddings with a random draw of posts of user embeddings from the control distribution of user embeddings, giving us some constant score Q bar J for each post J in treated users algorithm.
Does that mean the unconditional distribution remains the same?
Yeah, it does. Yeah. Okay. So for 2 million users, we randomly pick content or randomly pick user embeddings. And for 6 million users, it's business as usual. So here I'm working with a smaller sample of about 250,000
Just
users.
from the previous point, we just go back to the algorithm. It's not entirely obvious to me, right? Placing psi I by psi bar. I mean, the feed of the average user is not the same thing as the average feed necessarily.
So are you thinking in terms of
I don't know, it's just like I say we have like a left-right spectrum or something like that.
right?
The average user is somewhere in the middle.
Mm-hmm.
Then you get set prison posts. It's not the same thing as the distribution of posts from left to right.
But then this is basically representing the feed of the average user.
Yeah, which is not the same thing as the average.
Average feed, yeah, that's right. Right. I'm just like when I'm not exactly sure what is the best way to sort of convey that. So I keep calling it an average feed. But
But that contradicts what we were saying before about the distribution being this, the unconditional distribution being the same. Because if that story is right, then you would see less close the left, right, or the center relative to the user.
so I guess it depends where the average user is.
But still, it's a reduction in dispersion in some sense.
But it's a very small proportion of users on the platform. So, in the sense that some users are being brought to the mean, but they're not, the number of users who are being brought to the mean isn't that large. It's only 1% of the entire.
I'm trying to make a mathematical point, but I guess at least the way I understood it before was the treatment is switching the targeting algorithm with a random draw from the general feed, but it's different from this. But this is giving you a draw from the feed of a user characterized by psi bar.
So it is randomly drawn, but it's psi bar in the limit, in the sense that if I'm drawing randomly every day from the distribution of user embeddings in the control group, then when I aggregate the user embeddings over 1 month, they basically converge to the average user embedding because the random draw is being made every day.
Because so if I'm in the treatment group, I don't get sidebar, I get the random psi I every day.
every day, yeah.
Okay, so that is the
Yeah.
same thing as
Yeah.
the,
So this is
that's
just,
different, yeah.
yeah, I agree. This is a gross simplification.
Well, but the Q bar J is still the correct probability. That,
But the inner product is not the probability itself, it's something that.
I thought I understood Q by J to be a probability, but yes, if it's not a probability,
Does
Yeah.
get like fed into a local function?
It would, yeah,
Right.
on some sigmoid. Yeah,
that's where.
okay. So the baseline period here is December 2022, the full month, which I use to characterize user types, because the algorithm is functioning as normal. And the analysis period is the first month of the intervention period right now, but the experiment goes on until the end of the year in 2023. So the treatment mechanically shifts users' exposure to different topics. So just to give you an example, cluster number 50, which we saw as the news cluster, there is a reduction in exposure. So this is sort of like the first stage, and then that helps us establish these 5 facts. So the first fact is that the algorithm does keep users engaged, and this is seen in the overall reduction of engagement with the platform measured by the number of posts viewed. So treated users are seeing a lot less.
1 month period?
Yes, this is the first one. So this is February to March 2023.
And why not the 11, like the whole experiment?
Yeah, so I'm still sort of cleaning that data out. Yeah. But yeah, I wasn't sure initially if that should be a different paper or part of the same paper. Same paper.
Because I mean, one question I had was like just at the back of my mind is how do these treatment effects vary over time?
Over time,
They're learning, they're searching.
right,
Yeah. The strategic as well.
right.
So
Right, and it could be that also initially, they might be searching, thinking that they might be teaching the algorithm something. Yeah, right. So it will be very important to see how the search behavior changes over time.
For the example, the mentioned, they could do it through collaboration and for me that I about like if they do connect with my problem, so I had to like find
Right.
so how do you
So basically, yeah, so I built a partnership with the platform for a while and then basically work with the engineers to and
also the platform?
yes, they were on board. Okay. Yeah, so even though users are less engaged with the platform, they are reducing the total number of posts they're viewing. They are searching a lot more than before during the first month of the intervention. The second fact is that there is greater exposure to diverse feeds. Its content concentration, just in terms of exposure, is falling, but the shares, the HHI in shares is actually increasing. Yes, yeah. So the HHI is constructed with respect to these topics. And so I tried to write down a decomposition of this HHI, where I'm letting the number of views, the proportion of shares out of each category, and also the total number of shares be vary with treatment. And I can break down the treatment effect on this HHI into the mechanical response, which is just the response, which is just the change in exposure due to the treatment, the endogenous response, which is the change in overall shares, and finally the behavioral response, which is a change in the proportion of posts you're sharing out of each topic that you're being exposed to. And what I'm finding is
It's a different labels for the same categories, but it's interactive of their post behavioral responses.
yeah, I know this is just something like random naming. Yeah, I can change that for sure. Yeah, this is just the response and overall platforming.
It's just because you're finalizing for submission.
Yeah, no, for sure. I can work on those labels. But these are what I was using for the toxicity analysis as well. And here the overall treatment, the average treatment effect is positive. That is, the HHI in shares is increasing. And both of these, the mechanical response and the behavioral response is negative, but the only thing that is positive is the endogenous response, meaning that what is driving this increase in topic concentration is the fact that overall number of shares is falling. And also to think about the behavioral responses, I write down these two reduced form regressions. So the beta 1 divided by beta 0 is the percentage change in views in a particular topic, and alpha 1 divided by alpha 0 is the percentage change in shares. It generates three hypotheses. The first one being, if the percentage change in shares equals the percentage change in views, I think of users as being mechanical. If the percentage change in shares in a particular topic is less than the percentage change in views, I think of the users as being unresponsive. And finally, if this ratio is greater than 1, the users are perhaps a little too responsive. That is, say, if they weren't seeing toxic content before and now they're seeing it on their feed, they somehow think that it is more acceptable to say these things. And I find that responsiveness differs by different topics. So users aren't responsive towards political and religious content, but seem to be more responsive in changing their behavior when they see more or less news content.
One question, because you mentioned, so there's an increase in like the searching behavior. And I was
Mhm.
wondering, is that coming sort of from broadly all users? Or is there like a subset of users that drive this effect? And maybe also the effect of sort of increase in topic concentration afterwards?
Yeah, so here I'm just also breaking down what users are searching for. And it seems that most of the effect is again coming from like these good morning searchers.
Is it like, is there 1 million users who now are in the treatment group?
Mhm.
And I was just wondering, maybe there's just sort of 10% of these users that are now that were super attached to the platform before, and now they engage in like massive searching behavior.
Yeah.
They're also the ones that are driving the topic concentration.
Right, yeah, I can check at the user level, yeah. But I was just thinking of it in terms of what people are seeking out and characterize that type of users. And it seems like it's mostly the good morning type, and you'll see these guys keep coming back again.
So actually, it's just like trying to think back through what exactly the treatment is. So very like every day you get your like random draw. That's like,
Yeah,
it's kind of weird, right? Like one day I suddenly get like the grandma feed, and one day I get like the toxic racist feed.
yeah. No, for sure, I think, and I'm aggregating everything just because it's easier to handle the data at the aggregate level per month, but there is a lot more variation that could also be used for this analysis.
But just like as a user, it feels kind of funny, like I get like these swings across days.
Yeah. No, for sure. I mean, that also is probably why there is such a large drop in the total usage of the platform as well. Yeah. Okay. The third fact is that there are no effects on political attitudes and mental health. And these are very precisely estimated nulls because I can rule out effects that are as small as 0.02 standard deviations in political attitudes and 0.03 standard deviation in mental health. And finally, thinking about the toxic engagement bit, there is an overall, at the average user level, there is a reduction in the number of toxic posts that are viewed. And there is also a reduction in the number of toxic posts that are shared off the platform. And here again, users are unresponsive, as I can reject the hypothesis that this ratio of toxic shares, of percentage change in toxic shares to percentage change in toxic views equals 1. And behavioral responses sort of blunt the gains from this intervention, because even though most of the reduction in the number of toxic posts shared is also being driven by a reduction in the number of posts shared, I also find that this behavioral effect is basically going in the opposite direction. So that means that if we did not have this increase in the probability of sharing something toxic, when you view it, this reduction in the total number of toxic posts shared would have been larger. So thinking about the heterogeneous responses, I'm going to divide treated and control users into different quantiles based on their exposure to toxic content at baseline. The assumption here being that the algorithm does work at baseline, so that Q5 users who were seeing the most toxic content at baseline are the users who've taught their algorithm or trained their algorithm that they actually like that kind of content, and Q1 people are the opposite. So if you're in Q1 and you're in the control group, you're going to continue seeing low amounts of toxic content as compared to Q5 users who actually still see more toxic content if they're in the control group. As opposed to treated users for whom it shouldn't matter whether they're Q1 or Q5, they're going to on average see similar levels of toxic content if they're treated. And finally, the treatment effect. So here it's also because this includes content that they refer to from WhatsApp. So if someone shared it with them in their networks or WhatsApp. But the treatment effect on the number of toxic posts viewed is positive for Q1 users and negative for Q5 users. Here I also find that no, I know that they're coming from WhatsApp, but I don't know whose WhatsApp, who referred it to them.
Right.
Yeah, so the referrer column just says WhatsApp.
Yeah, that's maybe even roughly like time and post, like that, timestamp and post. I just like it's
Because if you see when they use the share to WhatsApp button,
Yeah,
exactly.
you see it going out, you see it coming in later. And so maybe,
but I don't know who they shared it with. And once they're coming back in, yeah, I also don't know who shared a different post with.
well, I guess then this would be a question of scale, but like. Suppose that this story gets shared by 1,000 people in the course of 3 hours. Then in the course of the next 6 hours, you see 5,000 people come in.
I
and
see.
go to the story. It's true that you can't individually identify which of 1,000 is next to the 5,000, but maybe they're still very interesting.
I see. Okay.
Yeah, I don't know if this paper, if the same paper or something else, but it seems as if there's
Right.
something.
I see.
interesting. I don't know.
That's interesting.
I don't think there will be issues there to try to identify it.
Yeah. The would be very creepy.
Collaborating with them. Like, find their lives away when they.
I mean, that's how I was able to do this too, right?
I think IRB is only relevant for the
Survey.
survey.
And that was also because I did on Brown's Qualtrics. If I was so initially I was doing it on their Qualtrics, and that again classified as secondary data collection. Okay. So I also find that it is the more extreme users, Q5 users, who disengage more, and I will show that with the total number of posts that are viewed. And Q5 users reduce the total number of posts viewed much more than Q1 users, who are again, like these are the people who are the good morning grandmas, and they are pretty inelastic in terms of their platform usage. I also find that this is consistent with the fact that in the endline survey, the more toxic users or users who are more toxic at baseline are users who self-report spending more time on other platforms when they are treated. I do not find a similar effect in the survey data for users who are not toxic. Sharing responsiveness is also heterogeneous in the sense that Q1 users who are now seeing more toxic content do not seem to be sharing more, but Q5 users who were seeing less are also now sharing less. And users are also sharing more toxic content when they view it. And again, this is more true for Q5 users than for Q1 users. And sort of tying this down to the decomposition that I started with, the total effect is the effect on the number of toxic posts shared, which is, I have change in engagement and not endogenous response, but I guess I'll change that to you. And mechanical change in the exposure to toxic content, overall change in engagement measured with a change in the number of shares, and finally the behavior change, which is the probability of sharing something toxic conditional on viewing it. And here, of course, for Q4 and Q5 users, there is a big mechanical reduction in the amount of toxicity they're engaging with, but most of these effects are being driven by change in engagement.
How unhappy was the platform with the change in engagement?
So we didn't talk about it. But I might have told you this before. So when I got a lot of resistance from the company's engineers to do this because their estimate of loss in engagement was about 10%. And the drop in time spent on the platform is actually 35% in my data.
They
So
underestimated how bad it was.
they really underestimated it. So I just we don't talk about it. So I'll conclude this paper here. So in this paper, I find that users seek out preferred content and user behavior is largely unresponsive with respect to exposure. And online behavior is determined by baseline preferences. And I try to put a number on by how much in the model that I did not show you because I also want to show you the other paper. And therefore, it is clear that regulating one platform is not as effective because the more extreme users seem to be spending more time on other platforms anyway. And turning off personalization is costly for platforms because the reduction in platform usage is larger than the engineers expected. So I will quickly shift